Hello, everyone. Good afternoon. Thank you for joining us here at Build in San Francisco, and thank you for coming to this talk on From 4 to 40 Inches, how you can develop Windows apps across multiple form factors. My name is Peter. I'm a program manager on the Windows Phone team, and we have a lot to talk about this afternoon, so I'm just going to get straight into it. Now, you heard today at the keynote about how Windows is basically running on everything now. From phones to phablets to all-in-ones to PCs to the Xbox to the Internet of Things. And we believe that the most successful developers are those that will embrace all of these form factors. It's no longer enough to be just a phone developer or just a PC developer or just a tablet developer. If you want to be successful, right, and who doesn't, you need to address all of these devices. And so that's what we're going to talk about today. Now, on one hand, this is a very, very simple topic to talk about. Right? We can say, if my device has a bigger screen, it probably has more pixels, and that means I can show more content to the user. Right? Sounds pretty simple. And similarly, if my machine has a higher DPI, that means there are more pixels, that means I get nicer graphics. Right? And whilst these two statements are basically true, they hide a lot of the complexity that is to be found in this area. And so today we'll walk through what some of those complexities are and why thinking in this simplistic term doesn't actually work very well when you're developing across multiple form factors. But before I go into any of the cool new stuff, I want to show you one of the most uneventful demos you will see at Build this week. And that is basically just a simple demo of Silverlight 8.1 upgrades. And we're doing this because we've said how we want to preserve your investment in existing code. So if you have an existing Silverlight 8.0 app and you upgrade it to Silverlight 8.1 because you want all of the cool new features that we've added in 8.1, we didn't want you to have to worry about now dealing with all these larger screen devices and having your layouts broken and all that kind of stuff. So very quick, very uneventful demo. I'm going to run this app, which is a Silverlight 8.0 app. And this is running on the 6-inch emulator. And I'm just going to click this basic info page, and it will tell me that Silverlight is telling the app this is an 480 by 853 pixel device, because that's what we tell all Silverlight apps. But it also knows, if it cares to go looking, that it actually is a 1080p device and 6 inches in diagonal size. So nothing particularly interesting here. But just showing you this is a Silverlight 8.0 app, this is the information it sees from the world. What I'm going to do is go into my project, and you can see right now it says it's a Windows Phone Silverlight 8 app. So I'm going to right-click on this and say, not that, and say retarget to Windows Phone 8.1. So let's go ahead and right-click, retarget to Windows Phone 8.1. It's warning me to make a backup if I need to. It will go and do a bunch of things to convert this to a Silverlight 8.1 app. And when it is done, we'll deploy the app again. And now it is running as a Silverlight 8.1 app. Oh, actually, it ran on the 4-inch emulator by default. Let me go ahead and run on the 6-inch emulator again, just so it's apples to apples comparison. Run the application again, deploying it to the 6-inch emulator, go to the basic info page, get screen info. It sees the same information. It sees it's 480 by 853, and if it wants to go looking, it can find out that it's a 1080p device. So very uneventful demo, but just letting you know that everything I'm about to talk about for the rest of the talk doesn't apply if you have a Silverlight app that you've upgraded. It only applies to the new XAML and HTML-based modern Windows apps. So with that, let's go back to the slides. And just a quick rundown, what you just saw. The point of Silverlight 8.1 is to give you all those cool new features, but with a friction-free upgrade. Right? So we didn't make you rethink your layouts. You can opt in to learning about these larger screen devices. I wrote a blog about this, aka.ms/WPSL large. If you want to go find it, that's where the app I was running came from. I encourage you to do that if you're a Silverlight developer. But of course, these Silverlight apps only run on Windows Phone OS. So it's great if you have an existing app and you want to keep running it on Windows Phone. But if you want to move to Windows, to the tablets, to the PCs, et cetera, you'll want to move to the new world, which is what we're going to talk about next. Now, this talk is going to be split into two basic sections. The first will talk about layout, and the second will talk about assets. And these, for the most part, are separate things. People conflate them and they get confused, but they're really separate things. And when I say layout, I'm talking about the positioning of UI objects on the screen, right? How many elements in a list, how many buttons across the screen, how many photos in my gallery, stuff like that. And when I'm talking about assets, I'm talking about things like PNGs, JPEGs, videos, 3D models, all those kind of graphical type things, right? And we're going to separate these two things. And we're going to talk about them in a 6-step journey. And we're going to start by talking about physical size and shape of devices. From there, we're going to take a slight detour and talk about viewing distance very briefly. And that will bring us to the notion of effective resolution. And that covers it for the layout side. After that, we'll then move on to assets, and we'll talk about the right detail level to have in your assets, how scale factors come into play, and finally, a little bit on mastering of your assets. Sorry, this thing doesn't work very far. So they are the 6 steps we're going to start with, we're going to take, and we're going to start with the physical size one right now. So I have here an animation of a bunch of different screen sizes, from 4 to 40 inches, right, the name of the talk. And what's important is that on this slide, I gave you the diagonal size in inches, and they're all to scale, by the way. But I did not put on there what the resolution of these devices is. I didn't say it was a 1080p 30-inch monitor. I didn't say it was a QHD 6-inch phone, right? It actually doesn't matter. What we want to talk about and what we want to think about is that the size of my application, not its resolution, is the thing that's most important when we're talking about layout and taking apps from 4 to 40 inches. So the next thing that is, I have to stop walking. The next thing that's important is thinking about the general shape of your application, right? Is it tall and thin? Is it short and wide? Or is it kind of squarish? And a lot of people, especially if they're phone or tablet developers, will think about orientation, right? Is my device portrait? Is my device landscape? And in the world where we're running on laptops and desktops that don't rotate, and when you're running on Windows PCs that have 2 or 3 or 4 apps all side by side, it turns out that the orientation of the device doesn't actually matter so much, right? We're worried about the overall shape of my app. Tall and thin, short and wide, or kind of squarish, right? So we're not particularly concerned about orientation. So with that bit of basic knowledge, I'm going to switch to a demo now of a game I wrote, a very simple game I wrote, to illustrate some of these concepts. Okay. Excuse me. So this is a very simple game of tic-tac-toe. Excuse me, not particularly complex app to write, but I just want to illustrate some of the concepts. So we have here a main screen of my app. I can say new game. I can say, yes, I love Windows, start my game. And we have here a very basic tic-tac-toe app, right? And I can play the game. And you notice there is a title at the top, there's the game board in the middle, and I have these kind of information bits on the right-hand side. Whose move is it next? How much time has elapsed? Etc. And watch that information bit on the right-hand side of the screen. If I snap my app to the left, we'll see that it takes more advantage of the fact that it's now a tall and thin app, or a squarish tall and thin app, rather than a wide app, and it's moved the information to the bottom. Now, as I make my app even smaller, you'll notice that given even less space, it now moves that into a 2-column layout. So it's crunching its information into a smaller space. And the title got smaller as well. And then as I move to the smallest size possible on Windows, you'll see that it moves back into a vertical alignment because it has no horizontal space. And of course, the game is still playable, and X is going to win. And you'll notice as well that the menus still work here. This app is fully functional, even in a little narrow strip. right? I can say new game, I can do this kind of stuff. And as I move, watch, the title reappeared, the font sizes are getting bigger, right? Back to full screen, right? So it's adapting to the amount of layout space that it has available. And I have the same app running on the phone. Let's go ahead and run it on the phone. And I accidentally shut down the 4-inch emulator, so let me go ahead and run that in the background. But if we look at the app on the phone, it looks very similar. It's not exactly the same, but I have some settings, and when this one loads, I'll actually switch back to the other app for a second. In my Windows app, I have the charm settings in the charm. So I hit the Windows I key, and I've got my app settings. Right? And here I can set things like the background that I want, and the default player name, and all that kind of stuff. And that was a Windows-specific version of settings. Now, if we go back to, here we have our two emulators again. Here we have the two Windows Phone emulators running in the settings. Same UI, but not running inside the charms anymore. This is running inside my app. And you'll see, for example, that whilst the Windows thing only had 2 radio buttons per line, I can fit 3 radio buttons here in the 4-inch emulator, and I can fit 4 items across in the 6-inch emulator because it's just bigger. So let's go ahead and just start a game on these, and it all works as you'd expect. Start. I can play the games. OK, so same experience on a phone screen. Now, one thing you'll notice here is that when I rotate the phone, it didn't move that information setting onto the right-hand side like it did on Windows. And that's a bug. And we will fix that bug in a later part of the talk. Don't you love demos that, like, oh, I have a bug, let me fix it. So that was a very quick first part of the demo for Tic-Tac-Toe, right? Just an app that is adaptive to its layout space. So we've talked about physical size and shape, and now let's talk a little bit about viewing distance. And this is a bit of a joke here. There's a person here thinking that if this 4-inch phone is an 800-pixel wide device, does that mean that Windows thinks a 40-inch screen is going to be 8,000 pixels wide? And they're kind of worried because they just bought a 4K TV, and as you know, 4K TV isn't even half that resolution. So they're worried that they've bought an obsolete television. And of course, the answer is no. Windows does not expect your 40-inch display to be 8,000 pixels. And this is where some remedial geometry comes into play. Anyone that did college, probably even high school geometry should know this. That green thing is an eye, and it's looking out into the distance. And we know that if there is an object x meters away and y meters tall, it takes up a certain angle of our view. And if we have an object that's twice as large, but twice as far away, it takes up the same angle, right? And so they appear to be the same size, even though one is actually twice as large as the other. And this is, again, remedial geometry, very basic stuff, but things that are closer appear larger than things that are further away, right? Very basic stuff, but it's just important along this journey. So if I have my phone and it's 10 feet away like my television, it's going to look really tiny, right? But if I bring the phone close to my face, where I'd normally hold it, well, lo and behold, it looks about the same size as my television, which is sitting across the room. So they take about the same angle of view. And this is important when we get to the next section, which is effective resolution. So we've said that my phone at 1 foot and my TV at 10 feet are about the same size, same angle of view. And that means that they have the same effective resolution in Windows. So if my phone had an effective resolution of x by y pixels, that means my TV has an effective resolution of x by y pixels. And that's because effective resolution really embraces this idea of viewing distance. And you'll notice that I still have not told you, was it a 1080p TV or was it a QHD phone? It doesn't matter, right? These things don't matter. For the most part, there are cases where they matter, but for the most part, you don't care about the resolution of the device you're running on. You worry about this thing called effective resolution. And so now I'm going to correct something that I said earlier. I told you a little bit of a lie. I said that app size not resolution, was most important. Well, now that we've learned about effective resolution, I can correct that mistake. And I can say that for layout purposes, the thing that matters most is effective resolution. Right? Not the size of the device, not how far away you sit from it, not its DPI, none of those things, because they're all taken into account by effective resolution. So we'll be working with devices, and of course this isn't all possible resolutions, but we'll be working with devices that are, say, 384 by 683 or 1920 by 1080, and so on. So this is the concept of effective resolution, independent of device, independent of viewing distance. So now let's go back and look at tic-tac-toe for a second and see how viewing distance how effective resolution comes into play. Okay. So I'm going to switch over to Blend, because that's a nicer way to do some of these demos. And here we have the main Windows main Windows layout page. And you can see here that it's currently in a mode that we might call wide, right? It's wider than it is tall. And I'm just dragging the design width slider here. And when it's wider than it is tall, the current font sizes and the current layout work fine, right? It looks really good. Excuse me. But as the screen starts to get smaller, as the app starts to get smaller, you'll notice the text at the bottom falls off the bottom of the screen, all right? And so when that happens, what we want to do is we want to change the layout characteristics of the app. And XAML has this great thing called visual states. And I am not going to tell you about visual states right now, because if you're already a XAML developer, you probably know what they are. And if you're not a XAML developer, I can't do it in 2 minutes, right? It's a talk in and of itself. But I'm going to use visual states to change the appearance of the app. So by default, it's in this wide view. And now we're closer to a square view, right? So you'll notice that from wide to square, the margins on the side reduced a little bit. And now my text appears correctly in the screen. Now, as I get even smaller and things fall off the bottom again, I can move to this thin layout. And now the title at the top, the tic-tac-toe Windows title, got even smaller, the margins got smaller, and the font inside the menu got smaller as well. And then as I get even smaller, up to the Windows minimum size, I'm going to switch into this rail mode. Actually, that's smaller than Windows goes. I'm going to switch into this rail mode, and that made the margins even smaller, made everything much smaller. And so things will actually appear as they're supposed to. Source control, no network here. I just need to rebuild, because this control is supposed to actually relay out itself. This little yellow icon here is telling me it's not. So here we'll see that the text of the menu itself got smaller as well. So here, notice even the text gets smaller. In addition to all the margins, the text gets smaller too. And that happens because the main menu pop-up, the thing that I'm hosting inside that page, also has visual states. And so inside here, it looks OK. As its available space becomes smaller and smaller, again, it starts to fall off the bottom. It has visual states called wide, thin, and rail. So it is also taking advantage of its space by making its margins bigger or smaller, its font sizes bigger or smaller, etc. So that's how we're actually changing the layout of our app based on the available size. And to do that, I am using a little helper I wrote called layout rules-based page, or layout rules-based user control. This is not rocket science. All this control really does is it's an easy way of mapping available width or available shape to a particular visual state that I switch to. So there is a little bit of code behind here, but it's not magic. It just says, given a particular size, what visual state should I move to? And I'll show you in a second, but most of this code and most of the UI is the same on Windows and Windows Phone. Just like they showed in the keynote, the bulk of the code is in the shared project. Then I have a little bit of code in Windows and a little bit of code in Windows Phone to deal with some of the more drastic UI differences. But let's figure out why my phone app wasn't working correctly. So here we have the phone app, and Here is the page that we wanted to look at with the tic-tac-toe and the information at the bottom. And if I go and rotate it into landscape, again, I'm talking about a device, so I can say landscape, but really, as the app, it is short and wide. We'll notice that it didn't actually rearrange. Now, before the talk, I went and created a visual state for this. So here is the tall version, which happens when the device is in portrait. And here is the wide version. And you'll notice that the heading changes in addition to the UI moving around. And all I really need to do to hook this up in the Layout Aware page is to just, again, do a mapping of the kind of shape this app is in, tall and thin versus short and wide, into one of these visual states. And I'm going to do that in Visual Studio just because it is easier. No, don't change anything. So here we are inside the page. I'm going to just use my layout rules-based page. And it just has a property called layout rules. For some reason, it is not liking me. Oh, thank you, thank you. Yes, demo fail. Thank you for pointing that out. Here we go. Local layout-based page dot layout rules. Thank you very much for that. And in here, I'm just going to add 2 rules. And they're going to be shape rules. So I'm going to say when my shape is wide, it automatically knows to switch to that visual state called wide. And when my shape is tall, it knows to switch into the tall mode. So now when I run this on the 4-inch emulator it's going to be, we'll notice that if we go to new game and say start, now we have the UI on the right, and when we rotate, it goes down to the bottom. So again, on the phone, we're now taking advantage of that extra space, not by doing anything particularly complex, but really just taking advantage of one of the features of XAML, which is this visual state management stuff. And in this particular example, again, I didn't talk about resolution at all. I just talked about, was my screen wide or was my screen tall? If we look at the main page inside Visual Studio, so if we look at the Windows main page, it does deal with actual sizes. So here, it's saying, if my minimum width is at least 1200, I'm wide. If my minimum width is at least 700, I'm square, and so on. And so this code will be posted into the Windows Phone developer blog soon. I can't promise you when. But again, it's not rocket science. It really is just changing visual states. And as I promised I would show you, most of the code here is in the shared project. So my game board is in the shared project. My layout rules, my main menu, my new game setup, my settings, all of these things are shared code. And they just happen to be in separate page containers inside Phone and Windows. And the other thing I want to show you very briefly is that the grid itself, the tic-tac-toe grid, the way that it managed to take up all of the available space that was available to it was it's using the viewbox. Right, so viewbox is a very simple control that just says, whatever I have inside of me, make it fit in whatever space I'm in. So that's a very good way to say, I have content, just blow it up to fit the right space. So that was a quick look at how we can do layout based on our available size, using things like visual state management. Right, so building adaptive apps, didn't go into this in too much detail, but building those shared UI components, like you saw in the keynote today, where everything is in the shared part of the project, is a key way of building these apps, because it lets you reuse your code, reuse your layout, reuse your assets. Right. We're going to combine them into platform-specific pages. So the Windows settings charm, for example, was a Windows-specific thing, versus on Windows Phone, it was a page within the app itself. We're going to adjust our layout based on our available size and shape, not resolution, just available size and shape. And I didn't talk about it specifically, but anyone that does things like MVVM knows that the cleaner your separation between your model and your view, the easier it is for you to juggle all these things and change them around whenever you see fit. So having a good separation between your view and your model is a great way to build these apps. So that basically covers it for layout. And now we're going to talk a little bit about assets. And we're going to talk about the detail level of assets. So can anyone tell me what this is? Quick, hands. Anyone know what this is? Sorry? Okay, this gentleman here knows it's a DVD-ROM drive. How did you know that? Okay, but yes, you're right. It is a DVD-ROM drive, but most people wouldn't be able to tell you that. And the reason is that it wasn't shown at an appropriate size. So when we see the DVD-ROM drive at its appropriate size, it looks great, right? It's kind of photorealistic. It has some nice shadowing and some like shiny bits on it and stuff like that. As the picture gets smaller, I can still see that it's a DVD drive, right? It still makes sense to me. But as we get even smaller, like it starts to look like a blurry mess, right? I just took that same asset and I kept making it smaller and smaller and smaller. And if you didn't see the two images on the left, you probably wouldn't know what the image on the right was. And as we get even smaller, it really is just that original blurry picture you saw that has far too much detail crammed into far too few pixels. So what we want to do is, as the size of that asset, the effective size of that asset gets smaller, we want to change to an appropriate amount of detail. Right? And so Windows will switch to a different representation of a DVD drive when you make the icons small. And we're going to do the same things in our apps as well. So for example, for the two images on the left, or the two sizes on the left, I might choose a large PNG called DVD large. And for the two images on the right, I might create one called DVD small.png. Right. Same thing, right? Picture of DVD drive, but two different representations based on its effective size, because the amount of detail that's crammed into that big image is just a blurry, blurry mess when we put it into a smaller image. And again, I haven't talked about DPI yet, right? So if you're thinking DPI, we haven't talked about DPI. This is all about the size of the asset. Right, so having talked about, and I'll give you a demo of this in a minute, but having talked about the detail level, we can talk about scale factors. So we know that devices have pixels. And here is a picture of the D that comes from that DVD drive. And we know that some displays will be more dense, right? There'll be twice as many pixels per unit of area. And they can render graphics better. So this D looks better on the screen on the right than it does on the screen on the left. But again, I haven't told you what the densities of these two screens are. I just told you that one was twice that of the other. So it could be 50 and 100. It could be 150 and 300. We don't really care, right? And that's because it's really the relative density between screens rather than their absolute density that matters. And this relative density we also might hear called scale factor or resolution scale are two terms that are used for this particular thing, particularly in Windows. And again, I still haven't told you what the DPI is. And so if you are a person using, for example, Photoshop to build assets for your applications, you might be familiar with this. This is the new file dialog in Photoshop. And it has a very helpful text box here that asks you what DPI you want, right? How many pixels per inch do you want in your asset that you're generating for your particular application? And it actually doesn't matter what number you put into there, except for two cases that I'll get to in a second. So you should really just ignore this value. This is kind of annoying, sorry. I have to stay over here. This clicker is not working. You should really ignore this value, right? Don't try and imagine what the DPI of your Surface Pro is or the DPI of your tablet is. It doesn't really matter what number you put into here. It only matters in two cases. Firstly, really, is if you had a photo from your last holiday or vacation and you wanted to print it on a 6x4 piece of paper, it matters then because that's printing it onto a physical piece of media. You need to know how many dots per inch because it's a physical piece of paper. The other thing is if you're generating assets with text in them and you got got the designs from a designer who told you what point size to use in that text, then you need to know what DPI they used. Right? But again, it doesn't matter what the number is, as long as it matches the number that they used. But as long as you're not printing things on physical paper, and as long as you're not trying to match exact font sizes that a designer gave you, and you're just drawing graphics, it actually doesn't matter what this number is. So just keep it at the default. So now I'm going to do a little bit of a demo about scale factors and detail level. And for this demo, I'm actually going to use HTML. So everything I'm talking about here is applicable not just to XAML apps, but to HTML apps as well. So the first demo of tic-tac-toe was in XAML, but the concepts apply to HTML. This demo is in HTML, but the concepts apply to XAML. OK, so I have a very boring app here. Let me just switch to Windows for a second. So I have, imagine, if you will, a stunning HTML-based app. I'm not an HTML expert, so I didn't put a lot of effort into this particular look of this demo. But you'll notice here that I've created a lovely kind of high-detail, 3D, faux, shadowy, etc. logo for my tic-tac-toe app. Right? And it looks pretty good. Right? You can see the shadows, you can see the fine lines. It looks pretty good. And that's when it's running at full size. And now let's say somewhere else in my app, I need to show a smaller version of my app's logo. Right? So I go in, and I put the same asset in, and I just make the size 1/3 the size. And I don't know how good the particular screens are that you're looking at back there, but it's kind of a blurry mess, kind of like that DVD icon that we first saw a while ago, because all the fine lines are getting squished into oblivion, right? And you can't really read the text. So it doesn't look good. And that's because the detail level in this asset isn't appropriate for the size of the asset on my app. So let's go ahead and fix that. So we're going to switch to Photoshop, actually. This is Photoshop Elements. And I created this nice high detail version of my logo. And we decided that when we tried to show it in a smaller space, it didn't look very good. So what I'm going to do is I'm going to make a semantically similar logo. Just like the DVD, small and large logos were semantically similar. They were a picture of a drive and a disk. I'm going to make this semantically similar logo. So it still has, the orange text, and it still has the blue grid with the game in progress. But rather than being 3D and faux drop shadow and all that kind of stuff, it's just very simple block lines and some nice bold text. And I'm going to output this as a different asset. And I already did that before the show, because that makes things easier. So if I go into my HTML, where before they both said logo large.png, I'm now going to make this one say logo small.png. And when I go ahead and run this, I mean, you know what's going to happen. Right? Now my big logo looks nice and fancy and lots of detail, and my small logo looks very nice. Not as fancy, but you can see it, you can read it, you understand what it is. So that's kind of how detail level plays into assets in your application. What about scale factor? So let me go ahead and run this on, switch to the Windows Phone version of the application, and I'm going to run it on the 6-inch emulator. Here we go. Again, this is a universal app. Just like the last one was a universal XAML app, this is a universal Windows web app. Exact same app running in both places, same HTML, same assets, same everything. And what's tricky for me to show you in this particular demo, because of the technology we're using, is what the asset actually looks like. So if I try and move into 100% zoom, to try and give you an idea of what this actually looks like, it's not a particularly good example because I've got a 1080p 6-inch phone running at 1366, 7068 on my laptop, projected through these projectors onto here. So it's not a very good simulation of what you would see in reality. But imagine, if you will, that you looked at this particular asset on this particular phone, and you said, boy, that looks a little bit blurry, right? Not that it looked squished and ugly like that first example did, but that the lines are blurry and you really want it to be crisp and nice. Right, so what do? Well, let me just make this visible again. Well, what we're going to do is we're going to go back to Photoshop, and we're going to go back to our high detail version of the asset, because that's the one we were looking at, and we're going to output it at a different size and give it a different name. And in the interests of this demo and the fact that you can't see blurry versus non-blurry on these screens, I'm going to artificially add the number 240 in the top left corner, just so we know that this is the new asset I've just rendered versus the old asset that used to be there. So this asset, its effective size in the HTML is 300 pixels by 300 pixels, and I'm going to multiply that by 2.4 to get an asset that's 2.4 times as large, because that 1080p 6-inch phone is about 2.4 times the density of the Windows app. So I didn't tell you what DPI was, remember? I just said it's as dense, 2.4% as dense as the other app. So let me go ahead and save this in Photoshop. And the size I want for this is 720 by 720, which is 300 times 2.4. I'm going to save that. And I'm going to put it, make sure this is the right directory. This is in my phone directory, good. I'm going to call it logo underscore large .scale-240.png. Let's just zoom in on that. And this is a naming convention that you use for naming assets in Windows and Windows Phone. I will not go into detail about this. Again, it's another big topic that could take a whole talk. But if you name assets with these scale qualifiers in the middle of them, magic happens and the right ones get picked at runtime. So that said, I'm just going to go and save this, and then switch back to my project. And then in my phone version of the project, in my images, I'm going to right-click, add existing item, and I'm going to pick that 240 scale asset we just generated. So it says 240 in the corner. Now I'm going to run this, and here we go. And, well, good and bad. The good thing is it picked up that 240% asset, right? The magic of that scale factor naming convention kicked in. It said, hey, I'm a higher density device. I should pick up the higher scale asset, and it picked it up. But the problem is that now it's way too big, right? It's gone way off the edges of the screen. And this is just a little tip for you. When you're working with these different scale assets in Windows, both in Windows and Windows Phone, both in XAML and in HTML, the part of the system that knows to pick up the scale 100 versus the scale 240 asset doesn't send that information onto the layout system, the HTML layout system or the XAML layout system. So the layout system just says, oh, that image was 3 times as big as the last one. Let me make it 3 times as big in the layout space, and undoes all the good work we did to make a higher density image. And what this really means is that when you are putting assets into your application, HTML or XAML, you should always specify the width. So now when I run this, it will come up, and it'll be the right size, and it is 2.4 times as dense as the previous image. So again, technology will probably fail me here, but if we look at this at full screen, in theory, that would be much, much crisper, right? But again, emulator on these screens, it's hard to see. But in theory, believe me, that would look much better. So that's how we can deal with different scale factors on different devices. OK, so that was detail level and scale factors. So quick review on this, the way we generated those assets. So the first thing is determine your layout size in effective pixels, right? Because this will drive things like your detail level, right? It also gives you a target to specify for your assets, right? That complex logo was 300 by 300, and the simpler logo was 100 by 100. Once you've done that, output the asset at that size, and put that in your shared project, because that will be shared between Windows and Windows Phone. Then, just like I did, multiply your intended size by 2.4. And this is just a recommendation. You can pick other numbers like 2.2 or 2 or 2.6 or 1.8. Our recommendation is 2.4 is probably a good place to start. Output that asset, and that asset goes into your phone-specific project. Because Windows, at this point in time, hardware doesn't go that high. Right? We have these super dense 1080p phones, but most PCs aren't quite that dense right now. So for now, only Windows Phone goes this high. Then don't do what we did in this talk and look at it on the emulator, which doesn't work very well for this particular reason, but look at it on the target devices you want to work on. Right? So pick a Nokia Lumia 1520, or pick a Surface Pro, or pick an Asus ZenBook. Right? Pick some representative hardware that you know your app is going to run on and that you know you want to look good, and check to see how things look. If it looks good enough, you're already done. Right? If you're only targeting desktop PC, obviously your apps can run anywhere, but if your target customer that you're working for only cares about desktop, maybe you only need a 100 scale asset. But if it doesn't look good on a particular device, then try an additional scale factor. So in addition to the 1.0 and the 2.4, try 1.4, which is the next highest one on Windows, or 1.8. And just keep doing this until you're done. But we think you should be done with just those 2 or maybe 3 versions of the asset. Right? It's kind of like performance. You need to set your goals and measure against those goals before you make changes to your application. Right? Don't go creating 10 copies of every asset out of the box at the beginning, because you might not actually need them. So that was scale factors, and now let's finally talk about mastering of assets, and this is a pretty simple one. We should be mastering our assets at the highest possible resolution, right? That's hopefully pretty obvious. If you can, you should be using a vector format, so Adobe Illustrator or SVG or some kind of a 3D rendering program. But if you can, put things inside vectors, because they don't have any particular limitations on how big or small they can go. If you can't use the vector format, then use bitmaps. I was using Photoshop, for example. And we recommend that the master asset that you create be at least 400% normal size. Now, you could go way above that if you wanted to. Some of the assets I used for this were at 1,000% intended size. But we think within the next few years, we're unlikely to get higher than a 400% scale device. Right? 2.4 is pretty high right now. We're unlikely to get higher than 400% in the foreseeable future. And of course, the bigger the asset is, the more disk space it takes up, the longer it takes to process, et cetera. Export them at the target scale factors that you require. So we just saw the 100 and the 240% scale factor. And that's it for masters. But there are two things you should two things to remember as well. The first one is that detail level, right? Just because the asset is 4 times larger than its intended size on the page doesn't mean it should have 4 times the detail, right? Always keep in mind, when it's at its intended size, is it going to look good or not, right? Keep it simple if the intended usage is small. And the other one is that if you only have a low-res asset, let's say you have an existing application and you rendered the assets once and you lost the masters, or you can't afford to pay a designer to do them again, or it's a picture you got from the web or anything like that, don't worry, right? Windows will work with only one version of any asset, right? And it'll scale it up or it'll scale it down to fit your application's needs. It just won't necessarily look as crisp as if you generated them at these additional scale factors. But don't worry, right? You only need one in order for your app to work. So that was mastering. And now we're coming towards the end of this talk, and some of you might be wondering, like, this is Build, right? It's a developer conference, you're developers. Where's the code, right? I mean, I showed you more Photoshop than I showed you Visual Studio, and we looked a little bit in Blend at some XAML. And you might be wondering, well, where is the code in this particular talk? And that's actually a point I wanted to make with this session, was that for the most part, now there are exceptions, but for the most part, this isn't something that you need to be down in the code worrying about, right? We never talked about physical resolutions of devices. We never talked about the physical DPIs of devices, right? We talked about effective resolution and layout in Blend, and we talked about detail level, and we talked about scale factors. But we didn't talk about all these low-level details, including code, right? For most cases, you don't actually need to be writing any code for this thing, other than the visual state switching that I showed you in XAML, which is a very trivial piece of code to write. But if you are curious, there is some code you can look at. And there is a type called display information. Oh, this went ahead of me. There is a type called display information, and you call get for current view on it. This is the new version of what used to be called display properties in Windows 8. And it has some properties on it that might be useful to you. If you do actually need to write code that is dependent on particular aspects of the display that you are on. So the first one is resolution scale. This one is on Windows. And this is the thing that tells you I am a 100% or a 140% or a 180% display. But as you saw with my asset that I ran earlier, I didn't have to say that the logo was 240 or the logo was 100. The system magically did that. So in most cases, you don't care about this. The next one is called raw pixels per view pixel, and this is on Windows Phone. It's a little bit unfortunate. This essentially replaces the previous one. Again, because as I said, Windows Phone has a lot higher density displays than Windows does. We needed to add a lot more values to this thing. And it didn't make sense to have an enum with all these new values on it, where each value was just a percentage number. So in Windows Phone, and moving forwards, we will now give you the raw pixels per view pixel, aka scale factor, just as a double. So 1.0, 2.0, 2.4, etc. Now, I keep telling you, don't worry about DPI, don't think about DPI. You can get the DPI. There are a couple of cases where this might be interesting. Number one, well, basically related. If you're trying to measure real-world objects, right? So you're building a ruler app, or you're from a hardware store, and you want someone to say, hey, I have a 3 7/8 inch screw, and you want to put it on the screen and match the right product so you can order the right product. This is the API for you, right? You want to know exactly how many pixels are in exactly how many inches. But ordinarily, you should ignore it, because if you decided to code against DPI and say, I was coding on this laptop, and I think this button should be 1 inch high. OK, that's great. Imagine a 1 inch button on this screen here, right, or that screen over there, right? No one would be able to read it, right? So we don't want to think in terms of inches unless we're building these kind of physical, real-world object type apps. And then lastly, you should ignore raw DPI, but you should really ignore and actually avoid this thing called logical DPI. Again, except for specific cases. And the main case here is that you're interoperating with Direct2D, so D-Write, those kind of things, where they have this legacy idea that everything is 96 dots per inch, and the world stopped at 96 dots per inch. And then there are some kind of multipliers on top of that. But never, 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 never use this property for any other reason, right? It sounds interesting. Hey, logical DPI, that sounds like what I want. No, you don't want it, right? Unless you're doing D2D or legacy code work, just ignore logical DPI. So let me just take a drink, and then I'll have one more thing specifically for Windows Phone developers. So if you are migrating an app, remember earlier on we said Silverlight 8 to 8.1, nothing changes. You get all the cool new stuff, nothing else changes. Great. But if you move to the new XAML platform, or you move to HTML, but you're more likely to move to the new XAML platform, there's something that you need to know. And that is that the minimum effective resolution for phones has changed. Now, I'm just going to dump some facts onto you right now, and I'm not going to really explain them to you, and I apologize for that, but I don't have time. There is a backstory if you want to know about it, but I'm just going to dump some facts on you, and you can trust me or not, but I'm just going to give you the information. I apologize, there's no big explanation. It's just the way it is. I'm happy to talk about it later. But this thing I'm dumping on you is that what we've done is we've had to change the minimum defined effective resolution of devices when you move from Silverlight to XAML. So for example, a Silverlight app, whether it was 8.0 or 8.1, or even 7.x, obviously the Lumia 920, this phone here, physically the panel is a 768 by 1280 resolution device. And Silverlight treats that as a 1.6 scale device, leading to the logical or effective resolution of 480 by 800, right? That's the effective resolution that all Silverlight apps have in a 15:9 configuration. But if you were to move to XAML or HTML, obviously the physical resolution of the device didn't change. It's still the same Lumia 920, but the scale factor changed to 2.0. And that means that the minimum effective resolution is now 384 by 640. Now, that doesn't mean that we come in with a saw and we hack off 20% of your phone. It just means that each one of those effective pixels takes up a few more physical pixels. The net result of all that is that if you have existing layout, or you have existing red lines from designers, or you have existing ideas about how things should look, multiply them all by 0.8 when you move from Silverlight to new XAML. So if you had a button that was 100 pixels wide in Silverlight, make it 80 pixels wide in XAML. Right? You get the idea. Again, I'm dumping this on you. You have to take it at face value. Happy to explain it later if you want. So wrapping up, and a bit of a call to action, I'm a huge believer in using the right words for things, right? Because words affect the way we think, and they affect what we think is possible in the world, right? And so I've been harping a lot in this talk about not worrying about DPI, not worrying about resolution, right? Physical display panel resolution, right? So when you're talking to your teammates, or you're talking to your customers, or you're talking to your designers, or even in your own head when you're reasoning about projects, think about effective resolution, right? Talk about the shape of an application. Talk or think about the scale factor of the assets and the detail level of the assets, right? These are good things, right? Except for some of those really edge cases, like I'm Home Depot and I'm building an app to tell you the size of a screw. Don't think about or talk about these things like physical resolution or device orientation or DPI. Because if you're talking or thinking about those specific topics, you're probably sending yourself down a bad path and you'll get into trouble, right? So use the right words, think in the right way, and your development will be much easier. So the next thing is architect for a flexible layout. So you saw it in the keynote at the start of the day, and I very briefly showed it in the tic-tac-toe demo. But if you start with smaller components and build them into larger pages, and then have the layout system work for you, moving things, shifting them around, things get much better, right? I didn't write a bunch of code reasoning about this stuff. I let the layout system do the work for me. And then finally, when we come to assets, focus on the right set, right? Not every possible asset, but the right set of assets. So we start with high-quality masters, either as vectors or as very high-resolution bitmaps. We generate only the assets we need, right? We don't go ahead and generate every possible copy of a particular asset and then realize that we wasted our time. And we ensure our detail level is correct, so we don't have low detail, huge, blurry, awful pictures, and we don't have high detail, small, blurry, awful pictures. So that's it for this particular talk. Again, thank you very much for coming to Build. Thank you very much for coming to this talk. Please evaluate this particular session and everything at Build. It's immensely helpful for us. It lets us know whether we're doing a good job or doing a bad job. So if you liked this, if you hated this, if you wished I'd had a better designer for some of my slides, anything you want to say, please give us the feedback. I see a lot of phones going up, which is good news. Just please give us feedback. It's the only way that we know to keep doing the things we're doing well and to stop doing the things we're doing badly, right? Which in the end benefits all of you if you come next year. So please do that. And with that, I'll take questions at the mics. Actually, I'll leave that up too. Thank you.